Good morning to Dr. Nahada, and my name is Kamila Suzy. Now I will explain about my dataset, which is the Brink'S dataset. Actually, this is the dataset about the amount collected from the New York City parking meters by some of the contractors. It is used to determine the amount of the tip from the parking meters collection by the Brink'S employee, which this Brink'S is an American security and protection company headquartered outside of the Richmond. So in my dataset, there is actually totally 47 observations in this research, and there are 4 variables. Only one is qualitative variables. So can see from my dataset, the Y is that for the amount collected by the contractor, and S1 is the number of months starting with the May 1997, and S2 is the amount collected by the city workers from the parking meter around the city hall, and S3 is the indicators that the Brink'S is the contractor. Then S4 is the number of collection days in the month for the workers. So S3, because S3 is the only qualitative variables for my research, so if the Brink'S is the contractor or is the indicators, so the dummy variables was set for the 1, otherwise it was set for the 0. So to do this analysis part, I have used the Minitab, the software Minitab, to find all the analysis and the interpretation. So I have used the graphical summary, which is get from the Minitab, the assistant, and the graphical analysis. Then I will choose to the graphical summary. Then I will get all the summary reports for the histogram, for the postport, and the confidence interval. So see from the summary report for the Y. So based on the histogram, it clearly see that the graph is negative skew distributed. So actually, if we use by visualize, we can see that the graph is normal distribution. But if we see from the Anderson normality test there, the skewness part there has stated that the distribution is negative 0.7247. It is negative value. So actually, this is a negative skew distribution. Also, we set after left skew distribution. Then see from the box plot graph also, we can know that there have the 3 outliers in the research, which is the observation 1, 9, and 10. So because we don't know the outliers is this influence through our research, so we need to do the further analysis to determine on the research will influence or has the strongly effect or not through the amount of the tip from the parking meters. So if it is affected, actually the researcher needs to do some actions to make all the analysis and the research more efficient and effective with the not any outlier to affect the result of the data. So we see from the basic statistics result, we also know that the mean of the amount of the tip appear collected by the contractor at the parking meter of the New York is 96,016,522%, which indicates that there is about 100 million thieves are still the things at the place in each year. So we move to the summary report for the X1. We can visualize that we can see there from the postplot part. It is all the data have the same height. So because this is variable of the number of months since the May 1997. The same height we can interpret like this is this research has continuous ongoing without any stop. So it means that every year they have go through the collection of the data. We have to start from every month. So the height of the distribution from the histogram will have the same height. The same means that they have non-stop and they have continuously to do the research to make this research result more effective. So we just directly move to the summary report for X3. For X2. From the graph, it shows that it's also visualized that the distribution of the graph is normal. But if we see from the data, it shows that the skewness value of the graph, which also indicate the negative value. So it means that it is also a left skewness distribution. And from the box plot of the summary, the researcher also know that there is one outliers for this research. So we can see from the graphical summary if we want to know which is the outliers. It is that the row, the observation we see for the Minitab, the observation 10 is the only outliers for the variable x2. So also if we want to detect it is not influence, we need to do the further analysis. If it is really influence, we need to remove and ongoing our research. But this is only simple statistic I do, so I haven't do the further analysis. So for the summary report for S3, the chart, because this is the only qualitative variables for my research, so I will do the bar chart only. Then the bar chart, we can see that the dummy variable of 1 is higher value than the 0. So it means that the frequency of the contractor in this research is a little bit higher than the amount of non-contractor. So in a simple word, we can say that the mostly of the person involved in this research is the Brink'S contractor. In simple, can say like this. Then for the X4 variables, we see for the summary report for the X4. The histogram of this summary report, we can see direct from the skewness value, which is also the negative. So same as the previous one, because it's a negative value, the skewness is a negative value. There is a negative skew distribution. Also, we can say like left skewness distribution. Then from the histogram also, we also know the minimum number of the collection days of the workers is 6 days per month, while the maximum number of the collection data days is 9 days per month. So it means that the workers help to collect the data is only 6 days. They will minimum they will collect with a minimum days with 6 and maximum days we will collected as 9. So the box plot also, we can see that there has only one outliers in our data set. So we can check also from the Minitab. I see from the graphical analysis. Then we can know that the only outliers is also the observation 10. So because they have the almost the three variables that the observation 10 is the outliers, so it is really needed to do the further analysis to test that it is not influence point. So as I said before, if it is the influence point, we need to remove it from the multicollinearity to check the multicollinearity and the VIF value. Then if it is influence, we need to remove and ongoing with the others analysis part. Then to investigate the correlation between the Y and the X variables, I have also used the Minitab to find the correlation between all the variables to try to investigate the pairwise relationship. And from the table of the pairwise, we can see that there is a strong relationship between the Y and the amount collected by the city workers from the parking meters around the city halls, which is the X2 variables. So we can see from the table the Pearson correlation R is equal to 0.6, which is exceed to the standard of 0.5. So we can say that it has a significant relationship in this research. And see for the another two variables, the number of months starting with the May 1997 and the number of collection days in the month for the workers. It does not show any significant change since the value of the Pearson correlation does not exceed the 0.5. So for the conclusion of this research is S2, the amount collected by the city workers is the most important variables affect the amount of thief from the parking meters collection by the Brink'S employees between the three quantitative variables. So it means that it will mostly affected through the data which collected by the Brink'S employee when they want to detect how many of the thief appears in the parking meter. So actually this is all my interpretation. So that's all from me. Thank you.